The laws of thermodynamics are relevant to environmental systems. So what I'd like to do is start off with talking about our first law. And the first law says energy is neither created or destroyed. Sometimes people might call it the law of conservation of energy. Of energy. So when we're talking about the law of conservation of energy, we have to think of the different kinds of systems we have. So I'll do an example of what it looks like in an open system, but for an isolated system. What this means is energy is constant in an isolated system. So the amount of energy in the universe has been the same since the universe has been around. But if we look at an open system, which is our living systems that naturally occur in nature, all of our energy comes from the sun. All right, and the sun is going to send its energy down in photons, and it's going to come to a happy little tree or something like that. So when we get our sun, we have a transformation here, and we have photosynthesis. And that's when we take energy in photons, and it's being converted into glucose, which is chemical energy. All right. And so all the energy we have has been converted from the sun via photosynthesis, and eventually the tree is going to produce something as for food, like for a happy little caterpillar. This is my caterpillar. All right. So this caterpillar is going to use this energy from the tree, and it's going to convert it from glucose to ATP so it can use it for work. And that's basically the first law of thermodynamics, where energy doesn't come from nowhere, we don't make it, we just convert it from the sun, from glucose, to usable energy that we can use. So let's talk about how much energy do we really get from the sun. So if we look at it, this is Earth. Here's our continents. Let's make some pretty blue water. And let's talk about all the energy the sun sends us. So the sun, about 30% of it gets sent back. About 50% goes into the oceans or is converted to heat. So that's a transformation. We've kind of lost all this energy that used to be usable energy. Now we have unusable energy as heat. And then just about 1% or less actually gets used in photosynthesis. And the rest of it is used to power the water cycle. So I think it's really interesting that if we look at this one right here, all of the energy that living systems use, save for the things at the bottom of the ocean, is less than 1% of what the sun actually sends down to the earth. So that covers the first law of thermodynamics, and we're going to look at the second law. I'll go back to green. And what the second law talks about is, we get energy from somewhere. What happens to that energy every time it's transferred? And we kind of lose usable energy every time. So the textbook definition is entropy of an isolated system. Not in equilibrium. Will tend to increase over time. For us, for the sake of environmental systems, it just means that energy conversions are not 100% efficient. The textbook definition uses this like entropy word, and I know a lot of you were struggling that when you were making your picture dictionaries. So when we're talking about entropy, it's the spreading out of energy. So that means the amount of usable energy decreases throughout a food chain, for example. And we can use this, and I'm going to draw another food chain. So we start off with the sun again, right? And then it goes to, let's do a flower this time. All right, so we only get max, so 1% gets sent to the sun, and only about 2% of that gets converted via photosynthesis. And then that plant is going to be eaten by a bug. And that bug only gets 10% of that energy that the flower had originally got, and then that bug gets eaten by some larger carnivore. All right, let's call it a dog. All right, and that dog only gets 10% of that bug's energy. And we talked about last class that a lot of this energy is lost as heat. This bug needs to move. So that energy goes elsewhere. So only about 10% is passed when we go from level to level. And here, this photosynthesis is not very efficient. We only get about 2%. So if we were to put this in a calculation, how much energy this dog got from the original process of the original amount of sun that got sent for photosynthesis is 0.002 times 0.1 times 0.1. This dog only gets, let me make sure, 0.0002% of the amount of energy that the sun had originally sent. You can also think about this as without using examples, as energy comes in. Ooh, that's a horrible arrow. I apologize. So energy comes in and it goes into a system. It's lost as heat or any movement. And then the amount of usable energy, see how my arrow gets smaller, the amount of usable energy for work decreases. For those of you who are less model inclined and who like a little math equation, you can do the same thing. So our total energy is going to equal work. So that's things like being able to use energy for movement, plus heat or other wasted energy. And that is a basic intro to first and second law of thermodynamics.